Which is holiday work batch 3. Question 1 is about earthquakes. Part A is about longitudinal waves. The answer they're looking for here would include talk about particles oscillating, and particularly the fact that in longitudinal waves the direction of oscillation is parallel to the direction of propagation. Part B really is a very straightforward application of V equals F lambda. The only possible pitfall is the fact that lambda must be in meters, not in kilometers. And part C, with the elephant, a fairly straightforward question again about speed is distance over time. When you calculate the time that it will take the P waves to get to the elephant, you should get an answer somewhere in the region of 350 seconds, slightly less, about 6 minutes. It takes the tidal wave 2 hours to travel the same distance, so you need to make an intelligent comment about what the elephant would be able to tell, or whether the elephant will be able to tell. Question 2 is a question about electricity. Part A, the length of the fuse wire, you just need to realise that the resistance is proportional to the length and do a calculation based on that. You should get an answer of about 0.0056 ohms. Part 2 is just a question about experimental uncertainty. Think about what issues might arise there. Part 3 uses the equation P equals VI, but you can substitute for V using Ohm's law, so P equals I squared R. If you do that correctly, you should get an answer of about 2.2 watts. The next part is just a very straightforward application of E equals mc delta theta, where theta is the change in temperature. The correct answer is 35.5 joules. If you've not got that, do the question again. And then the next part is energy equals power times time. Power, of course, being measured in watts or joules per second. If time is in seconds, and you use that equation there on the board, you should get an answer of just over 16 seconds, 16.1 seconds. And the fourth part is just to do with what happens in the wire when the temperature increases and why resistance increases. If you can't remember the answer to that, look it up in the textbook. It's to do with the increased vibration of the lattice ions. And finally, in this particular video clip, question 3 about Neil Armstrong and the surface of the moon. Part 1, S equals ut plus a half at squared, but in this case, u is 0 because the hammer and the feather are dropped from rest. Acceleration should be somewhere in the region of 1.73 meters per second squared. Don't forget the units. There's no air resistance in part 2, and so you've got a constant accelerating force, the weight of the objects, and so you would expect the resultant force to be the same, and so they will accelerate at a constant rate. Part B, weight equals mass times acceleration due to gravity. W equals mg. Don't forget they're on the moon, so it's not 9.81 in this case. Part C, the final part of this question, you need to resolve the velocity into its vertical and its horizontal components. So vertically, the velocity equals 45 sine 20. Horizontally, for the second part, the horizontal component equals 45 cos 20. You should find that the time of flight is 18.1 seconds and that the distance the ball travels is about 766 meters, if you've done the calculations correctly.